Automotive tooling companies face constant challenges to deliver quality molds on time and on budget whilst trying to achieve margins in a highly competitive market. The use of new technology and increased machine utilization, therefore, can address the needs of more complex and accurate tooling, allowing you to regain a competitive advantage. Collaboration through shared access to files enables the ability to find and reuse existing part data quickly. CAD data can be rapidly imported, analysed, fixed or enhanced in preparation for tooling design. Before it becomes expensive, the critical mold tool design questions need to be answered early in the manufacturing process. Simulation analysis of the design at an early stage can be used to identify potential mold defects, allowing part modifications to be made long before the tooling goes into production, whilst the introduction of conformal cooling inserts can reduce molding cycle times, increasing the productivity of your molds. Once the tooling design is completed and ready for manufacture, focus turns to improving the quality, accuracy, repeatability and finish of the machining processes. High efficiency toolpaths can reduce project lead times, with minimal tool lengths achieved through the use of full utilization of multi-axis machines to improve surface finish. Tool axis control can fine-tune the output desired for your machines, with simulation and verification before machining providing confidence for unattended production. Automated part alignment can produce quick, accurate and consistent setups. Part verification, whilst the component is still on the machine, can be used to check accuracy before moving to subsequent operations or final inspection. Unexpected variation can be detected and remedied immediately, minimizing costs and improving efficiency. For conformal cooling inserts with their complex internal channels, additive manufacturing can be used. Builds can be simulated to predict any issues before being sliced with the 2D toolpaths necessary to control the laser to print the part. Printed parts can then be quickly and easily machined for accurate final finishing. For the finest part details, electrodes can be used. Extracted directly from the model, electrodes can be machined and inspected, as well as being positioned accurately in the EDM machine itself within an automated, closed-loop workflow, all of which can help you deliver high-value automotive tooling.